We're going to learn about proportions today in similar triangles and how we can use proportions to calculate a bunch of different things in triangles. So altitudes, medians, angle bisectors, perimeters, and areas, all of those of similar triangles have proportions related to them, and so we can compute those lengths of related segments in similar triangles. So first theorem, in similar triangles, of course, the lengths of the altitudes that extending to corresponding sides are in the same ratio as the length of those sides. So, for example, here we have two altitudes, and these triangles are similar, right? ABC is similar to triangle DEF. And so the ratio of the corresponding sides, AC over DF, is equal to 2, because 4 over 2 is 2, which means that if we wanted to find out the altitude CX, we would have to, or the ratio of CX to FY is also 2, because the ratios are the same. In similar triangles, the lengths of medians also have the same ratio as the corresponding side. So here are medians AD and XW. Let's say that given that these triangles are similar, we want to find the median AD. So we know that we have the ratio of corresponding sides, 12 over 8, which is 3/2, right? So 12 over 8. So to get from 8 to 12, we multiply by the ratio. So 8 times 3/2 equals 12. So if we want to get from here to this median, we're going to multiply by 3/2 again. 6 times 3/2 is 9. So the length of AD is 9. In similar triangles, the angle bisectors also have the same ratio as the corresponding sides. The perimeters of similar triangles have the same ratio as corresponding sides. And then the areas of similar triangles, they have the same ratio, except for it's not exactly the same ratio. You have to square the ratio of corresponding sides. So for example, if the ratio of corresponding sides is 3, you would have to square it and make it 9, and that is the ratio for the area. So for example, the area of triangle DEF is 6 units. Find the area of ABC. So first thing we have to do is we have to find the ratio. What is the ratio? So what is 12 divided by 4? 12 divided by 4 is 3. So the ratio of the sides of the triangle is 3. But remember, if we want the ratio of the area, we have to square the ratio of the sides. So 3 squared is 9. So if we want to know what the area of this bigger triangle is, we have to multiply the area of the smaller triangle by 9. So the area of the smaller triangle was 6, so 6 times 9 is 54, which means the area of this larger triangle is 54. All right, let's do some practice problems. In this one, we have ABC is similar to GEF. Notice ABC is going this way. GEF is going this way, which means that AB corresponds with GE. They look like they don't, but they do. We have to read the order of the letters here. Don't get confused by the image. It says AD and GH are altitudes, which means we can use our theorems about ratios. And we want to find AB. So we know that the ratio of 4 over 3 is equal to the ratio of x plus 1 over x minus 1. So we can set up a relation. 3 over 4 is equal to x minus 1 over x plus 4. You can do it that way, or you could do 4 over 3 equals x plus 1 over x minus 1. You just have to make sure that the 3 goes with x minus 1 and the 4 goes with x plus 1 because those are the triangles that they're associated with. So when we cross multiply here, we get 3 times x plus 1 on one side equals 4 times x minus 1 on the other side. We'll use our distributed property. 3 times x is 3x, 3 times 1 is 3, equals 4 times x is 4x, and 4 times negative 1 is minus 4. So now we're going to solve for x. First thing I want to do is get all my x's on the same sides. So I'm going to subtract 3x from both sides because that leaves me just 3 on the right-hand side. And then 4x minus 3x is just x. And then I still have my minus 4. So now I'm left with the equation 3 equals x minus 4. Now to solve for x, I'm going to add 4 to both sides, and I get x equals 7. So x equals 7, but AB is x plus 1, not just x. So AB is 7 plus 1, so AB is equal to 8. Our next two triangles, we have triangle top is similar to triangle bag, and OD and AR are angle bisectors. So that means we get to use our theorems. We want to find the angle bisector OD. Okay, so we're going to set up a proportion, right? So we know that the ratio of the sides is equal to the ratio of the angle bisector. So the ratio of the sides is 9 to 12. So 9 over 12 equals, since we started with 9, we're going to start with the angle bisector over here, which is 6. 6 over, we don't know this angle bisector, so we're going to leave it as x. Again, instead of saying 9 over 12 equals 6 over x, you could have said 12 over 9 equals x over 6. It doesn't matter as long as whatever number you start with, on your next ratio, you have to start with the number corresponding to it. So when we cross multiply, 9 times x is 9x, 12 times 6 is 72. We divide both sides by 9 to solve for x, and we get x is equal to 8. So triangle ABC is similar to triangle DEF. The perimeter of ABC is 144, and the perimeter of DEF is 16. We have side AB is equal to 12, and we want to find side DE. So remember, the ratio of the perimeters is equal to the ratio of the sides, which means that 144 over 16 equals 12 over x. The reason why I chose to write 12 first is because I started with 144, and remember, it has to correspond. AB corresponds with the perimeter of ABC. So 144 over 16 equals 12 over x. I cross multiply, and I'll get 144x equals 12 times 16. If I'm doing this by hand, I end up with the fraction 12 over 9, which reduces to 4 over 3. But if I'm using my calculator, I'll get approximately 1.3. Your turn. Try 2 through 6 evens.